Okay, let's see how this works. So x plus 3. Did we have to do letter B? Yes. Okay. So letter B says we're writing an expression for 8 less than twice the value of x. 8 less than twice the value of x. Remember that less than is the weird one that makes us swap the order. So we have to change the order for that. How do I show twice something? What does it mean twice? Are you writing this down because you said you needed help with it? Okay. How do I show twice something? You multiply by 2. So 2x minus 8. Did we have to do letter C? No. Okay. Did we have to do letter D? Yes. Okay. So letter D says we're trying to represent a number for this expression, and the expression is 2 less than 1/4 of n. Well, this is the fraction 1/4 of means multiply. So I have 1/4 n. We know that less than means subtract, and it's one of those weird ones. We have to change the order. So 1/4 n minus 2. Did we have to do letter E? No. What about letter F? Okay. So letter F says -2 times the sum of. What does the sum of mean? Parentheses, and it's going to be an addition parenthesis. So I have -2 parenthesis, and what two things am I adding together? Y and 7. Y plus 7. Okay. Did we have to do letter G? Yes. Okay. So letter G. We're doing 3 times the difference of, that's going to be a subtraction problem. So that's where I have 3 times, and then my parentheses, the difference of a number and 6, a number and 6, and it's increased by 4 times the number. So 3 parenthesis n minus 6 plus 4n. Did we have to do letter H? No. What about letter I? Okay. Letter I. The difference of, that means I'm going to use a parenthesis, 3 times the number after it was increased by, this is wrong. My example is wrong. So the difference of 3 times a number after it was increased by 3 and twice that number. There should have been a minus symbol right here. Should have been a minus. So we're taking 3 parenthesis n plus 3 minus 2 n. So on my example that I actually did, this should have been a minus sign right here. This is wrong. This should have been a minus sign. That's why I scribbled it out. Okay. Did we have to do letter J? Okay. Jane, you had that one correct. It says the quotient of, so quotient is a division problem. So I'm going to draw a fraction bar. 2 times h and 10 more than h plus 10. If you had 10 plus h in the denominator, is that okay? Yes, it is. Did we have to do letter K? K or L? Okay. Sebastian, are you the one that said h plus 10 is okay, is the same as 10 plus h? No. Who said when I asked that question? Good job, Jason. Okay. All right. I'm going to go to the module for today just so we can talk about what the plan is. So did we do a warm-up today? Yeah, this is block 4, no warm-up. Did we finish checking our homework? Yes. Okay, so we're going to do notes, combine like terms, and distribute with combine like terms, okay? So your notes should be your note packet. Keep your note packet out. Keep your note packet out. Okay. So, do you have your notes? No? You already filled out. That's all right. You can just use that. Okay. All right. If I have 3 apples and I add 2 more, how many apples do I have?
6.
3 plus 2 is 5. So I want you to write 5 apples right here. If I have 3 and I add 2, I have a total of 5 apples. Okay? But if I have 3 apples and I add 2 oranges, how many apples do I have?
3.
3, yeah. Do you guys remember combining like terms? Yes or no? Yeah. So combining like terms means that I can only add them if I have the same variable. Yeah. 3x and 2x equals 5x. Okay? Does that make sense? Did you already put it away? Keep it out, Walter. Keep it out. I want you to look at it. Okay. So let's combine some like terms. So if I have an expression that has more than one variable, I'm going to give you an example. If I have an expression and it has more than one variable, so 3x minus 2y plus 6x minus 4. This expression has 2 variables. It has x's in it and it has y's. Do you see that? If I have an expression that has more than one variable, what do I have to look for? That's to solve them.
Combine like terms.
Yeah, what do you mean by combine like terms? I'm looking for the same what?
Same x or y.
So same variable. And above that, I'm going to write letter. You need to have the same letter. Okay? How is 3x and 4x squared different? What's different about them?
4x is squared.
It's squared. So not only do I have to have the same variable, but I also have to have the same, what is that called when I square something or cube it? What's that little number up to the top called? Say it again. Yeah. Not only do I have to have the same variable, I also have to have the same exponent. Okay? Does that make sense? Same variable, same exponent. Awesome. Same variable, same exponent. So now we're going to do some vocabulary terms, and this is important. You have to know what these terms are because you will probably see them on a quiz. Okay. So when I talk about a term is any number. It can be any variable, and it can be a number with a variable. So So I'm going to go to this example right here. We look at this example right here. Here's a number, -4. Here's a variable, x. And then I have two examples of a number with a variable. Each one of these is called a term. Each one of those are called terms. When I talk about like terms have the same, what did we say? Like terms have the same variable and the same exponent. Same variable and the same exponent. They have to have the same. Okay? When you combine like terms, you add or subtract the terms that have the same variable with the same exponent. That's what that means. Okay, I'm going to be over in a second. I want you to look at your notes. We're not drawing, okay? You have notes you can follow along as well. We're not going to doodle, you're not ignoring me, okay? A constant. What is a constant? What does the word constant mean? Stays the same, right? Something that stays the same. So when I think of this expression right here, do any of these terms stay the same? Huh? What about the number? Does -4 change? Is -4 always -4? Yeah, it is. So a constant is just another way of saying any number without a variable. So it's just a number all by itself. Okay? Any number without a variable, like -4. Any number without a variable. What does coefficient mean? What do you think, Tyler? No idea? Maddie, what do you think? Have you heard the term coefficient before? Everett, what do you think? A variable is a variable, but the coefficient is close to the variable. Daniela? Yeah, it's the number attached to the variable. The coefficient is the number, God bless you, attached to the variable. Thank you. It's the number attached to the variable. Okay? An expression. Sarah, this is yours for today. I've already passed them out, and then these are what we talked about. No, you're totally fine. You're fine. An expression is any term added. Let's see. That's not what I want. I just want to write. It's when you add or subtract terms. This is an expression. This is a bunch of terms joined by addition and subtraction signs. It's just a bunch of things joined by addition and subtraction. Okay? That is what an expression is. So today, we are going to combine like terms, meaning that we're going to group the things together that are the same. And we're also going to practice distributing. Okay, so we got to I'm gonna scroll up. Is everybody doing okay with that? Okay. Me. I think I'll be okay. It died on me last class period, but I've had it plugged in for a whole block. It's just my fan is not shutting off. I feel like it's gonna blow up. It just keeps like running, and you know what I mean.
That's a new one?
Okay. So I want everyone to look at this. What did we say a term was? We're gonna look at terms. So I want you to circle them. Okay? So this is a term. It's a number with a variable. A number and a letter together with a term. This is a term. It's a number, and terms always include the sign in front of it. So that's the number 5. This is a term. What is this term called? What is this number? Negative 3y. And this is a term. 2x. Okay? So those are terms. They're just, remember we said they could be numbers, variables, or numbers and variables together. So all of these things that I have circled together, we're looking at like, same, mismo, right? Is mismo same? So which ones have the same letter? 7x and 2x. They have the same letter. Okay? Same letter. Does that make sense? All right. Let's talk about coefficients. We said that a coefficient, Daniela, you told us what a coefficient was. It's the number that's what? Attached to the variable. So coefficient is the number that's attached to the variable. Okay. So my coefficients are, did it sharpen for you, Frida? Did it work? Okay. So my coefficients are 7, because that's attached to the x. Negative 3, because that's attached to a letter. And 2. Okay? The coefficient is the number that's hooked up to a letter. Okay? That's all it is. It's just the number that's hooked up to a letter. Remember, what did we say about a constant? What was a constant? It's the number. So the constant is just a number. The only number that we have here that does not have a variable attached to it is the number 5. Okay? Does that make sense? A little bit? Okay. Oh, my MacBook's right here. Or my Chromebook's, sorry. Okay, let's do this next one. I want someone to come up and tell me, let's try and identify the terms. Who wants to come up and try to circle the terms? Sebastian. Sebastian, thank you so much for volunteering. I appreciate it very much. Pick any color you want, Sebastian. Circle up the terms. Make sure you include the sign in front of it. There you go. You're awesome, Sebastian. Thank you. Perfect. Awesome. Nope, that's perfect. Thank you. Terms. Remember, it's the number and the sign in front of it. Sebastian, thank you so much. So negative 2x, 4y, negative 5, and 2x squared. Okay? Are any of these terms, do any of these terms have the same letter?
Negative 2x and 2x squared. But they don't have the same exponent.
So are they like terms?
No.
Everett, what do you think?
Negative 2x and 2x to the second power.
Okay, so what did we say about like terms? What do we know about like terms? They have to have the same variable with the same what? Do they have the same exponent? No. So there are no like terms. Because this x is not the same as this. This does not have an exponent. This one does. Does that make sense? Jacob, is that good? All right. Coefficients. What are the numbers attached to the variables? Jane, help us out. What are all the coefficients?
Negative 2.
Negative 2,
4
4,
and 2.
and 2. Negative 2 is attached to a variable, 4 and 2. Okay, are we good with that? What's the only constant?
Negative 5.
Negative 5. Awesome. Feel okay about that? Okay, we're going to practice combining them, meaning we're going to simplify an expression. We are going to simplify. Did you get it, Tyler?
No.
Do you need another pencil? Here, look over here. All of these are labeled pencil. Pencil. It's for you to use. So I have it, and they're already sharpened. Okay. Here you go, sir. You're so welcome. Okay. So let's look at this first example. And I'm going to circle the terms. Is there another term that matches 3x? Is there another term that has the same letter, the same variable as 3x? Jane. Negative x. So what is 3x minus x?
2x.
What is it? 2x. Because this really is 1x, right? There's a 1 there. We don't write it, but so this is 2x. Are there any other terms that are the same? Positive 1 and a positive 2. 1 plus 2 equals 3. So this expression, when I simplify it, becomes 2x plus 3. Okay. Good. Frida, does that make sense? Okay. And hello? Good. All right. Let's do example number 4. Is there another term that has the variable a and only the variable a? Tyler.
2A.
2a. So what is 3a plus 2a?
5A.
5a. Are you okay with that? Does that make sense? 3A plus 2A is 5A. Okay? Is there another term that looks like this? No. So what do I do with it?
Leave it isolated.
Just bring it down. It just gets added because it has no matches. Okay? Is there a term that matches this?
-6.
Okay? What is 5 minus 6?
-1.
-1. -1b.
Or you could just put B.
You could put what?
You could just leave it at B if you want.
I could just put it at minus b. Yes, you're right. 5 minus 6 is -1. I know, you guys. I know this is crazy. Craziness. Okay. Let's look at example number 5. Okay. Is there any term that has an x raised to the second power?
7x to the power of 2.
7x to the power 2. And Jane, start raising your hand because other people had their hands raised just so we're giving everybody a chance. Please and thank you. So what is -4 plus 7? This is -4 plus 7. What does that equal? Yeah, good job, both of you. 3x squared. Okay. Is there a term, make sure you raise your hands, is there a term that has just a y all by itself? Raise your hand. Tyler.
6y.
Look at it again. Look at the whole term. What's in front of the 6? Subtract -6y. You got to remember to include the sign, Tyler, okay? -6y. So this says -2 minus 6. What does this become? Are the signs the same or are they different?
They're the same. Doesn't it become positive?
No, but if the signs are the same, we add. Same signs, add, and keep. Same signs, add. What's 2 plus 6? 8. Keep the sign. -8y. Is there a term that matches y squared? What do you think, Edward? Is there a term that has a y squared? No. So this just comes right over here. Plus 3y squared. It doesn't have a match. Okay? Hayden, is there a term that matches the 8x?
No.
No. So what do I do with this positive 8x?
Bring it down.
I just add it. Okay? What do we think? Okay. So I'm going to set a timer for 15 minutes. 15 minutes. And you guys are going to work on your homework. Okay? So that is this. I'm going to give you 15 minutes to work on this. And then when the 15 minutes is done, we're going to do the next page. We're going to just start on the next page. I'm not going to get it all done. We're just going to start it. Okay?
You good with me taking some out?
Yes. $15 minutes. Miss Sarah, will you come back in 15 minutes?
I will.
It's Mrs. Benko, right?
It is.